Welcome to Maths Bridge. Let's learn Java programming. Folks, please do visit us at our YouTube channel Maths Bridge. I think you are already subscribed to the channel. If you have not, please do subscribe the channel and then support us. Thank you and then happy learning. Here is our today's agenda. In this session, we're gonna look at a concept of a software debugging. First thing, debugging means like there is a bug in the software which we need to actually identify and fix it. That's called debugging, right? You narrow down, you understand the problem and then narrow down the problem, fix the problem. That sort of sense that I'm getting from the debugging. We are a software programmers or developers, we love to actually develop a code. That's good. But we always have some room left where we can unknowingly we're introducing some kind of bugs, right? So the question here is like having the bug in the source code is fine, but you should have a good amount of debugging skills and analytical skills to fix that kind of a problem. That's the context that we are going to discuss today. So what is meant by debugging? Debugging is a process of identifying, analyzing, and fixing errors. Errors means in our cases like software bugs or defects. Okay, in a software program. So debugging typically involves diagnosing both syntactical errors and the runtime errors is called a logical errors. Okay, syntax errors will be taken care during your compilation time anyway, but runtime errors where the program logic, something produces like an unintended behavior, right? So then definitely it is not what you are expected to see on software programming, right? While executing functionally, if it is deviating from what you wanted to, then you got to go and actually figure that out and fix it, isn't it? So that is called as actually the debugging, and then the essential skill that every software developer or programmer should have it. It helps ensure reliability, performance, and correctness of software systems, software programs. The key steps in debugging are listed: identifying a bug, reproducing bug, isolate the source of bug, fix the bug, test the bug, document the issue and fix. If we can reiterate again, when we sense that like a software is not working as expected, there is an issue with the program. That means now what you have to do, you have to realize that there is a bug in the code. That's what meaning of identification of bug. When you test it, you can figure that out, like the expected versus like actual is deviating from whatever your traceability matrix is. Then you say that there is a defect, there is a bug in the source code. But is it like a reproducible? It's just like once in a while that you are seeing the bug. So it has to be reproducible, because unless otherwise you don't get a for sure confidence that you're gonna fix it, right? So it should be reproducible. You have to understand the nature of the bug. Is it like an intern? Rarely happens at every time that you can reproduce. Every time if you are able to reproduce, that means like you 100% sure that there is a bug in it, and that bug can be like you can definitely fix it. A possibility of fixing reproducible bugs are having little higher probability than intern are rarely happens cases. That's what I was trying to reiterate. Once you are able to reproduce the problem, and then you try to understand the source code and then figure that out, like where that would be, and isolate the portion of the source code which causes these defects. Once you know that portion, then you have to deep dive into it and then fix the bug. Once you solve the the issue, then what you have to do is like you test thoroughly, ensuring that all the test coverages actually takes place, and then give a confident result, right? Then once you get the test confidence for validating the fix, then what you have to do is like best practice always documenting the issue versus like fix that you provided for that area. These are the critical and key important steps that we follow in debugging process. A common debugging tools and techniques that we use to follow is these are using a printf statements. You can do using integrated debugging tools like an IDE, integrated development environment, right? To IDE, Eclipse IDE, for instance, where you can do like inline source debugging. That debugging tool actually is going to give us like a facility for doing that. So the other part is like logging using log4j frameworks. This is a one more a powerful the tools and techniques that we have to use for actual debugging, software debugging. And then fourth one foremost is like automated testing. The best practice of actually while doing a software development, you always have a like a test driven development way of doing things during your software development. So you do test first and then do code next. Test driven development, TDD. Okay, we can talk about these things actually in subsequent uh, sessions. So are you clear now? Software debugging, key steps in debugging, common debugging tools and techniques. Okay, so debugging is an essential skill for a software developers or programmers. It helps ensure reliability, performance, and correctness of software program. Any software program, not this concept is not just only for a Java programming. Any software programming, these skills are essential. These are the common skill that one should have to have. Got it? Let's quickly skim through this one. So I have a software program here, and then I have test results here. So I'm not actually getting into the more details inside each line, but I will just see output. What this means is like, okay, value 1, value 2, num1, num2, and then sum. What is input is given? 100 and 200 is given. Oh, you got 250. How much it in fact 100 plus 200 is like 300, but why you got it 250? So that means there is a problem in the code. Is it clear? So you have to identify. Is it you keep actually rerun this program and see whether you are getting same results. Looks like you are getting same results, so you are able to reproduce the bug. That sort of a demonstration. I'm not getting the details. It's a simple program, so you can do that. But what if like if you are like in millions of the code in front of you and then you are trying to debug the problems, right? So the one way you are seeing is like looking at this console messages, text messages, from which you are trying to figure that out, like what is actually happening, right? Good. This is one case that we are saying like how the sense of like how you want to identify and reproduce the bug. One of the method that we are going to use for the debugging is like using a print statements. So in case of Java, we are using like a system.out.println, right? That is a library method function that you use to print string on console. All right. So what you have to do is like wherever you feel there is a essential for you to monitor certain things, you started using that print statements so that you will bring that into the console so that you can easily see what stage we have the problem, right? This example basically demonstrates by looking at these logs, right? Because I added a bunch of statements in each stage. I ran the program, I produced an output. Now I'm seeing initially at 0 0 0. Okay, good, that is fine. Here 100 100, but some of the given two number 0. Probably this was a stage where I am not yet even add these two variables. Okay, up to this is fine. If I here I see that I think it looks like I added 100 and 100 200 and 300. Yes, looks fine. Now I see here 100 and 200 250. Oh, looks like I think something problem in this area. Until this step I think I'm fine. After that something else is happening, but that would actually causing this end result is wrong. Got it? So this way you will be able to narrow down certain things using print statements. You may not be able to actually use for every case, but case by case if you can think of like this is the one of the debugging technique that we follow to narrow down the the defect in your software programming. Does it make sense? Beautiful. If you are using like an IDE, like an Eclipse, in our cases, like a, the Java in what you call integrated development environment, wherein for every program that you write, you can actually run it in the two ways. One is a production mode, other one is like a production mode is means like a run mode. The second option would be the debug mode. Debug mode means like you can temporarily stop the program wherever you want by using like a break statements, and then you run the program stepwise. Each line you can execute, and then you can also monitor all the variables, what value that is storing currently, right? On each step that you can monitor them and then see how it happens. If you look at my screen, so I have this program, I have breakpoint that I set it up while control comes to the main program, and then I just doing like a step in, means like executing each step once at a time. By doing that, I'm also actually monitoring all my variables like a num1, num2, num3. If I look at this position, means like line number 13 is already executed. By now what I see, num1, num2 are zeros, and then some instead of 0 is now is actually sum is also 0, right? But num1 is actually filled with 100. So 100, 0, 0 is what I'm seeing in the current state of my variable. If I started executing, then I know how my values of this variable is getting changed, modified. This is in another way that you can actually debug the source code using your IDE inbuilt debugging tools. This again, when to use, how to use, and all is like based out of your use case. If it is a very exhaustive application, multi-threading, where you may not have a control to do this IDE way of investigation, then this is ruled out. But otherwise, for certain things where you can still able to investigate the problem by inline debugging, I think this is one of the options that you can think about it. It depends, right? Case by case you can think through, but this is one of the debugging technique that we follow in narrow down the defect and then fix the defect and test the defect. One of the best and good method is using a logging mechanism. What that means is, see, having a too many printf statements, console messages is nice to have, but it's kind of a burden to the program, right? So why would you need to actually run the program continuously and then throwing something onto the console? There is a two disadvantages. One, you are throwing so much of dump on the console. Second thing, console messages are kind of like appears and disappears kind of thing, right? You are not going to have them for future reference. And the one more part that we see is like too many printf statements is basically program execution takes little more while, because every system.out.println statement is like an executable statement. It is just to execute for displaying certain messages on the console, but not really essential for the program, right? That's why if you look at, I think log4j framework is very, very, very useful, because it has the feature set. But the first primary thing is like all the log messages can be routed to a dedicated log file, so you can refer them later point of time. And then second part is like while logging, it actually gives you like a time. If you look at my screen here, I can see like each log message has a timestamp, so that way I know at what instant that I had happened to see this issue, right? Referencing with your timeline as well, is it? And second part is like level of logs can be controlled. You have, this framework is basically supports debug, info, one, error, fatal, this sort of errors. So you can filter them. You can set the log level, and then you can either you can include, you can exclude certain things. So for instance, right, I have created all this, but I am using like if you look at my debug category, info category, one category, error category, fatal category, these sort of log messages that I already included. But if you look at an output, right, what I'm getting is like a error and a fatal. By default, it displays only error and fatal. All the debug info warn got filtered out. Do you see? So that means like even though you have a log statements, you still can filter them, when to execute, when to actually, let that exclude from your execution. So that's the beauty of like, log4j framework. So one important thing that I just wanted to let you know that, log4j is a popular open source logging framework, written in Java. It is a thread safe, fast, provides like a name and log hierarchy. Right, log4j is distributed under open source Apache software license. Recently, you might know, the people who are already working in software industry, they would know for sure. Log4j 1.x reached to the end of the life, and hence there was a serious recommendation that I think everyone should actually upgrade to the log4j2. And currently, I also used log4j2, for this demonstration. So I am going to show you like each thing in the subsequent sessions, but for the context of what are the ways we use in our software practices for debugging software programs when you have a defect in this program, right? So what we have seen is like using printf, using IDE, right, and basically console messages and inline debugging. And we also talks about like using a framework. Now let's look at automated testing. Means like test automation. Prevention is better than cure, isn't it? So that's why while writing a software programming or developing a software programs, you always keep in mind that like how you're going to test the code, right? So there is a different approaches that we have. If you look at it very broadly, we have a two type of testing: manual testing and automation testing. Manual testing means what? Executing test cases manually without any software tools, any testing tools. That's called manual testing. Absolutely is manual. When you look at automation testing means using like, for example, precisely in case of Java, we have a JUnit at unit test framework, which we use for writing a software, unit test cases for the program that you're going to develop. So JUnit is a most popular Java unit testing framework. It is again a open source framework. Right, JUnit is used to write and run repeatable automated tests. So let's say like you have the code and you identify the 100 different unit test cases. And then you build all the 100 test cases. So every time you run and see like what is an output. As long as your 100 test cases are kind of a pass, that means like your 100 out of 100 is like green. That means your software is good. Let's say someone actually made a modification to the code. Then you still go and actually run the test suite. When you do run the test suite, if it is actually giving like your 100 is as green as previously, then I'm good. Otherwise, you would end up seeing like the failure of test cases because of some modification done. Then you easily know that what piece recently gone into a source base, so that you will only isolate that problem into that new changes and then make sure they are addressing their issue properly, correctly, right? So that's why like you can do early cut using unit test frameworks. So today, if you look at the one of the agile practice that we are following is like test automation compulsory in every level. Clear? Only cases where we feel that like an automation is not possible, that is the only place where we do manual testing, like a system testing. Okay, certain portion of the system testing that we do manual, but otherwise everything highly encouraged to actually work on automation testing, right? That's all for today. Good luck, guys. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. Happy learning. Thank you. Stay tuned to upcoming sessions.